Assalamualaikum warahmatullahi ta'ala wabarakatuh. So today we continue our class with subtopic isothermal process. So today we need to understand the isothermal process. So the iso, so they refer to the same. That means is and then the thermal is refer to the temperature. So that means what is meant by the isothermal process in concept. That means the gas undergo the process at the constant temperature. Okay, so we continue. When a gas expands or is compressed, so at constant temperature, the gas is said to undergo an isothermal inspection or isothermal compression. So that means when the gas expands or compresses at constant temperature, that means the gas is undergo the isothermal process. It can be the isothermal expansion or isothermal compression. Either one. Okay, so we continue. For n mole of gas, careful, we are referred to the mole. For n mole of gas, we have already seen that the pressure P, the volume V, and the absolute temperature T are related by the equation PV equals to the nRT. Then because T is a constant, so we can write as a PV is equal to the constant. Because n number of mole is constant, R also constant, and then the temperature also constant. So we can write all this one as a constant. So we have the equation PV is equal to the constant. So and then what we can say, this gas obey the Boyle's law, because the Boyle's law is a PV equals to the constant, or we can write as a P initial, V initial is equals to P final, V final. So this one is situation 1, and here is the situation 2. Okay, we continue. So we continue for the isothermal process. Now we refer to the graph. So the graph pressure, here is the pressure versus the volume. Here is the volume. So for the isothermal process, so from we can see P is inversely proportional to V at constant temperature. So here P is inversely proportional to V, because from the PV is a constant, then we can write as a P is inversely proportional to the volume. So the graph is this one. Okay, so the first graph at the temperature, for example, is 473 Kelvin. So temperature is constant, so this one is the graph. And then for the second graph here, for the temperature, constant temperature 373 Kelvin. And then the third graph, so for the constant temperature 273 Kelvin. So we have the graph for the pressure against the volume. So this graph refer to the n mole of gas. Okay, so we continue. So we need to understand the work done. Okay. internal work done in expansion. So that means the gas expand. Gas expand. So the heat taken in when a gas expand isothermally is the heat equivalent of the mechanical work done. Okay, because there is no change in the internal energy U of an ideal gas because the temperature is constant. Okay, so we have the equation for the change in the internal energy, delta U and F over 2 R dt. So dt is equal to 0. Why? Because the temperature is constant. So when the temperature is constant, that means so the internal energy is equal to 0 joule. So that the first thing we have for the isothermal process, we have the internal energy is equal to 0. Okay, so we continue. Okay, so we have the first law of thermodynamics. First law of thermodynamics, the Q, the heat supply or the heat loss is equal to change of the internal energy plus the work done by the gas. Either the gas is expansion or the gas is expanding. So because T is remain constant, so that means the internal energy is equal to 0. Delta U is a change of internal energy. Internal energy. So therefore we have the, from this equation, so we have this one. You have the Q, so delta U plus the W here is equal to 0. So we have the work done by on the gas, so that means the heat is equal to the work done. That means the heat supplied to the system or loss from the system is fully give to the gas to work done, to do work by or on the gas. So that means from this diagram, so we refer to the piston system, the heat supply into the gas. So because the temperature is constant, so that means the internal energy is 0. So we have here is the P1 is a Pi Vy in the initial condition. Then after we supply the heat to the gas, so the gas expands, so we have the final condition. Okay, so very clear. Okay, then you have to understand this one. So I repeat, so the heat supply to the gas, so the gas just only do the work. Because the gas do the work, so what happened to the piston system? They start to expand. So we have the two conditions here. So initial condition and then they move to the final condition. So we continue. Okay, so then from the graph pressure versus the volume for the isothermal process, so here is the initial state. So the Pi, Vi, then here is the final state, P final, V final. So the gas is expand from here to here. Gas expand from here to here. So that work done by the gas on the surroundings. So we can calculate the work done by the gas by find the area under the graph. So area under the graph is equals to the work done. But okay, so we continue. Let W is the work done by the gas on the surrounding. So we integration P delta V. So we replace from the gas equation here. Gas equation, so we replace the PV P here, so we have this equation. Because P is equal to nRT over the V, so we replace here, so we have this one. So we integrate for the volume, nRT is a constant, so we can move here, so get here. That means we have this equation. So from the identity of the trigonometry, ln V final equals to the over the V initial is equal to the ln V final minus the ln V initial. Here to same with here, because the identity of trigonometry. Then we already know the Q from the first law of thermodynamics, so we can calculate the Q and RT ln V final over the V initial. So then we can get the heat supply or loss from the system, the gas system. N is a number of mole, R is a gas constant 8.31, T is a temperature, constant temperature, V is the Vf is the final volume, and I is the initial volume. So we can get, at this we can get the Q, then Q is equal to the W. That one is the notes about the isothermal process. For that, thank you very much. Assalamualaikum warahmatullahi taala wabarakatuh.